Hello everyone. Here is how I love geometry. I'm Mr. Cao. This problem is from 2011 Aime12, problem number 10. It says a circle with center O has radius 25. There is a circle and a radius 25. Chord AB of length 30 and chord CD of length 14 intersecting at a point P. Okay. Let's draw a scratch diagram. Okay, just so this is the circle O, and the radius 25, and there is a chord AB is 30. Let's call AB, and CD. Another chord CD is 14 intersect P. The distance between the midpoint of two chords is 12. So another chord I just use is 14 CD. That's the midpoint, and here midpoint, and that means M, and this is M. So this is 12. That's 12. This is 14, so here is 7. And this is 30, so here is 15, right? And it says, the quadrilateral OP intersect P, so here is P. They wanted to find as OP squared, so let us to find OP squared. Okay, midpoint in that's the chord of a circle. So and this is the center. So of course we should connect them. Why? Because that's the midpoint. So is a perpendicular bisector, right? So and we know the radius is how much? 25. So 25 here is 15, so this is 20, right? 3, 4, 5. And also we connected this one, this midpoint, and the center. So 7, 25, so here is 24. So let us to find the OP squared. OP squared, yeah. We think about what? So this is right angle and this is right angle. So it means we easily to find OMPN. They are cyclic quadrilateral. Cyclic quadrilateral. Quadrilateral. It means all of these 4 points in the same second circle. And not just so, because this is right angle, right? This is at angle. It means OP is this circle's diameter. So what we can think about? Yes, we think about which theorem? Sine law, right? Sine law. So it means this, if we, here, yeah, it's so clearly now. Triangle OMN, that's is the circumscribed triangle. And according to the sine law, so if we use one side, for example, MM over sine angle NOM, it will be 2R, right? 2r, it means OP. 2r, that's radius, 2 times radius, that's diameter. So now the problem is m is 12 and this 24, 20. So in this triangle, we can easily to find which, let us say this angle. If I say this angle is alpha, we can use cosine law, right? Here is sine law. Now we can use cosine law. Cosine law to find the angle cosine alpha. If we find cosine alpha, then we easily to find sine alpha, right? If we got sine alpha, we can easily got OP, then OP square, yeah, is solved, right? And the left problem is just for calculation. Okay, we know cosine alpha, how to get that? And we use 24 squared plus 20 squared minus 12 squared divided by 2 times 24 times 20. So how to get it? 24 squared 576 plus 400 minus 144 over 2 times 3 times 8, that's 24 times 4 times 5, that's 20. So 576, 400, that's 976 minus 144, that's 832. So it's 832 over, 2 times 3 times 8 times 4 times 5. So divided by 8, 104. Divided by 4, that's 26, right? Divided by 2, so it's 13 divided by, so equals 15. 13 over 15. That's cosine alpha. Now we can find the sine alpha. Sine alpha equals square root of 1 minus 13 over 15 squared. So that's 15, and 225 minus 169, that's how much? 170 is 56. Square root of 6 over 15, right? Of course, we can do something to get a little more. So that's 2 square root 14, right? 4 times 14 is 56, so that's 15. Okay, now we can use this to find OP. And then we directly find OP squared, right? OP squared, m is 12. m over sine alpha, then squared, that equals OP squared, right? So it will be how much? m is 12, sine alpha is 2 square root 14, 15, then squared, so 144, here is 4 times 14, then 15 squared times 225. So we divided by 4, divided by 2 is 72, divided by 4, so it's 36, right? 36. Then we can divide it by 2, so it's 18 over 7. So now 18, let's try it here, 18 times 225 is 2 times 9 times 25 times 9. That's 200, that's 18, so it's 50 times 81, so 40, 50, right? So it's 40, 50 over 7. And the problem that has to get m plus n divided by 1000 as a remainder. So this is m, this is n. So m plus n divided by 1000, the remainder is 0.57. Done. That's it, right? Yeah, it's okay. Of course, we have another way. different ways to try it. Almost the same. If, let us say, we have known, we can easily use the Heron formula to get the area of the triangle OMN, right? If we got this one, we can easily to find, we can get this. Then we can also find the sine alpha, because the area also we can use 1/2 24 times 20 times sine. We can get sine alpha from this sine alpha, right? Also, we can find the sine. If we say this angle is beta, we also can find the sine beta, right? Why I got sine beta? Because beta, this angle also beta, because that's cyclic quadralateral. So this angle and this angle got the same corresponding arc, so they're the same angle. And because if we find the sine alpha, then we can use 20 MO over OP to find the sine beta. Then we can find OP, right? Also, we can get the answer. And sometimes maybe we can think about, because they are cyclic quadrilateral, maybe we will think about Ptolemy theorem, right? Ptolemy theorem tell us if we say OP equals X, that's but this way maybe got a lot of calculation. If OP is X, then PM will be the X squared minus 20 squared. And then we can get MPN, right? This, and equals X squared minus 24 squared. Then according to the Ptolemy theorem, we can get PM times OM plus MO times PN equals PO, that's X, times NM, that's 12, right? If we plug in what we have known into this formula, we can solve X. But I think we have a lot of calculations here. Of course, the final answer should be the same. I just introduced different ways. And when we meet the problem like this way, I think it's just to combination of a lot of basic concept knowledge and skills, especially for if we really understand the cyclic quadrilateral, and we easily to find when do the problems chord and the center of the circle midpoint, that's the perpendicular bisector, we will find the right triangle and triangle triples. We can easily to find this 20, this 24, and we know this triangle. If we know all three sides, then we know all the things about this triangle. If we know all of this triangle and the cyclic quadrilateral, we can easily find the diameter or the radius of this circumcircle. So we can find the answer. I hope you can enjoy it. Thank you.